Hi there. Hey, thanks for clicking on your lesson and taking care of business, right? I appreciate the fact that you're taking time to watch this lesson at home. So the good news is I don't think this is going to be a very long lesson. So that's kind of a bonus, right? We're moving along in our second unit of study, which is about real numbers, or rational numbers, I guess we could also say. And we are at the point now where we are going to start to talk about multiplying and dividing monomials. So if you have your textbook handy, it's lesson 9.3. Yes, paper. Yes, pencil. Yes, calculator. All right? Hey, let's just get straight into this so we can get going through this lesson. Like I said, it's not very long, and I don't think you're going to think it's very, very difficult either. This is kind of one of the more easy lessons that we're going to tackle in this unit of study. So we're going to be talking about multiplying and then in a little bit dividing monomials. Remember that a monomial is just a term, right? It could be a letter or a variable like m. There we go, if my marker would work. It could be a term such as 8. That's a monomial. Or it could be a combination of a number and a letter like 5c, right? That's a monomial. So these are each monomials, and we're going to talk about how to multiply them, especially when they have exponents. This is essentially what we're really going to talk about, is when monomials have exponents. So it says here in blue, to multiply numbers that have the same base, or you could think of it as the same variable, otherwise known as monomials, like I just showed you there a second ago, and they have exponents on them, the trick is to add the exponents together. So I know this is going to seem really weird, but if you're ever given a situation, and you certainly will be in math class, where you have a monomial like 5 to the second power, right? The base is 5 and the exponent is 2. Multiplying that by another monomial, 5 to the fourth power, where the base again is 5. So you notice that they have the same bases, and it has an exponent of 4. So we have a base of 5 with an exponent of 2 times a base of 5 with an exponent of 4. The quick rule of thumb is that the base will stay the same, and what you do to the exponents, oddly enough, is that you add them. So now we have 5 to the 6th power. Now let me break this down for you and show you why this works. Let's think about, back up to the beginning of the problem. What does 5 to the second power really mean? It does not mean 5 times 2. If you said that, you're going to give me gray hair. It does not mean 5 times 2. It means 5 times 5, right? And we're multiplying that, here, bring this multiplication symbol down, times 5 to the fourth power. That does not mean 5 times 4. It means 4 5s are being multiplied by 2 5s, right? So that's, in a nutshell, what this problem is telling us. We're taking 5 to the second power times 5 to the fourth power. And when you string it all out like this and you kind of expand the problem, it's pretty easy to see why we end up with our answer of 5 to the 6th power, because there are 1, 2, 3, 4, 5, 6 5s, which is our base number, being multiplied together. And you don't have to go any further than this. I don't want to know the actual solution. I don't want you to evaluate it all the way. So that's kind of the long expanded form, but in a nutshell, all we did was add the exponents, 2 plus 4, and got 6. Right? It's not hard. Let's try some. Find each product, express using exponents. Okay, so they don't want us to write like final answers. They want us to leave our answers with a base number and an exponent. So obviously the base number here is 4. And 4 to the third power times 4 to the fifth power, it's not 4 to the 15th power. You don't multiply the 3 and the 5. You add them. So it's actually 4 to the 8th power. End of story. You're done. How about this next one? 6 times 6 to the 4th. Obviously the base number is 6. Well, there's an exponent of 4. What's the exponent on this term, on that monomial? I don't see one, do you? Oh, it's a case of the invisible 1. Right? There's a 1 there. So it's really 6 to the 5th. How about the one with 12? 12 to the third times 12, which is really 12 to the first power. Add the exponents, 12 to the fourth. Right? Pretty self-explanatory. Even if they throw variables at us. Who cares? These are still monomials. The base is still the same. Now I have a b times b squared. So that's a b to the first power times b to the second power makes b to the third, otherwise known as b cubed. Moving on down, y to the sixth power times y to the third, right? So you would imagine that you have 6 y's times 3 more y's, y to the ninth power. What about this next guy? Well, do you see anything that you can multiply? I do. I can multiply the 2 and the 8. That gives me 16. Now, xxx times xxxx, right? The 3 x's and the 4 x's makes how many? 7. So 16, x to the 7th power. How about down below here? Multiply the 5 and the negative 3, negative 15. A to the second times a to the fourth is not a to the 8th. We don't multiply them, we add them. It's a to the 6th power. Got to add those exponents. So, when we're multiplying monomials with the same base, we add the exponents. When we divide monomials that have the same base or the same variable, check this out. We're going to be subtracting the exponents. So let's go back and think about that for a minute. When we were multiplying monomials with the same base, we were adding their exponents together. And now that we are dividing monomials that have the same base, we're going to be subtracting their exponents. So the example that I have typed up here says 8 to the 7th power being divided by 8 to the 5th power, and I get an answer of 8 to the 2nd power. Where does this 2 come from? It comes from this 7 minus the 5. Now, let me write this out kind of in expanded form so you can see why this works. Let's think about what 8 to the 7th means. It means you have 7 eighths. There they are, being divided by 5 eighths. Now, when you have an 8 on top and an 8 on bottom, they cancel each other out. So imagine that this first 8 on top being divided by the 8 on bottom. What is 8 divided by 8? It's a 1, isn't it? Right. So you can cancel those out. And then that cancels, and those guys cancel, and cancel there, and cancel there. And what's left? 8 squared is what's left, which lo and behold, bang, is your final answer. Right? And that's even going to work with variables. Let's try some. Find each quotient, right? Quotient means divide. So you got 8 to the 5th power being divided by 8 to the 3rd. So what's left? What's your final answer? 8 to the 2nd power, right? 8 to the 5 minus 3, which is 8 to the 2nd. Let's scoot on down to the 3 to the 9th power being divided by 3 to the 2nd power. So mathematically, you're going to do 3 to the 9 minus 2, if you want to show it that way, which gives you an answer of 3 to the 7th, final answer. Right? We're just subtracting the exponents. Well, even if it's a variable, c to the 7th divided by c to the 2nd. So you have 7 c's on top and you have 2 c's on bottom, and they're going to cancel and cancel, and what would you have left? You'd have 5 c's on top, c to the 5th power. Or you could think of it as c to the 7 minus 2, which would take you there. What about the next one? B to the 7th power divided by b to the 6th. What does that mean? B to the 7 minus 6, right? So it's b to the first power, otherwise known as plain old b. I would accept either answer there. And that is it. No more, no less. When you're multiplying monomials with the same base, you actually add the exponents. And when you're dividing monomials with the same base, you subtract the exponents. So, here's what we're going to be working on in class. And if you'd like to go ahead and take a look at it ahead of time, you're certainly welcome to. But if you want to use class time and ask questions and check your answers in class, I will certainly be available for that as well. All right. Thanks.